Hi there, welcome to the second part of the series Azure Virtual Network Basics. In the previous module, we discussed about VNet peering, and in this session, we will take a step further to understand the scenario where the networks are connected in a hub and spoke architecture, and the spoke virtual networks are able to communicate with each other. In this session, we will try to learn about network virtual appliances and user-defined routes. Hi, my name is Neeraj Kumar. I'm a cloud advocate, architect, and author, and I'm very happy to be your instructor for this course as well. Stay tuned. Let's first try to understand what Network Virtual Appliance is in theory. Azure Network Virtual Appliance, which is an NVA, it is used to enhance high availability of applications and interoperability between networks in special configurations. An NVA is typically used to control the flow of traffic between network segments classified with different security levels. For example, a demilitarized zone, a DMZ, virtual network, and the public internet. Network appliances support network functionality and services in the form of virtual machines in your virtual networks and deployments. And there are many offerings in the Azure Marketplace that you can use as per your convenience, such as Citrix, Cisco, Aviatrix, Barracuda, Brocade, and whatnot. So there are many offerings, you can choose from them. Although you can also configure routing and remote access server on your Windows virtual machine. But usually organizations, they tend to use one of the offerings that is already provided in the Azure Marketplace. Now that you understand what a network virtual appliance is, let me explain it to you with an example to make it more clear. We have a virtual network named as VNet A. We are considering this as a hub virtual network. This has an IP address space of 10.0.0.0/16, and it has three subnets, subnet 1, subnet 2, and DMZ. This DMZ is for demilitarized zone. Each one of the subnets have one virtual machine each, and the virtual machine within the DMZ is named as VNet A, NVA. NVA is for Network Virtual Appliance. It has an IP address of 10.0.3.4. And how have I configured it as a routing server, as a NVA? What I've done is I have configured the RRAS role on this server, which is Remote and Routing Access Server. This hub virtual network is connected with one of the spoke VNet, which is the VNet B. It has an IP address space of 10.10.0.0/16. This one also has two subnets, and each of the subnets have one virtual machine each. The hub virtual network is also paired with another spoke VNet, which is VNet C. This one has an IP address space of 10.2.0.0/16 with two subnets, subnet 1 and subnet 2. And again here, we have two virtual machines each in each of the subnets. These spoke VNets are connected to the hub virtual network via the VNet peering. Although in the real world scenario, the architecture will be much more complex, but just for the demo purposes, I have kept it very simple. Now, if virtual machine 1 within the spoke VNet B wants to communicate with the virtual machine 1 of spoke VNet C, for that, this needs to route via the network virtual appliance. And the network virtual appliance will be able to route the request from the source to the destination. In order to do that, we need a routing table. And within the routing table, we need to define the routes. And these are known as user-defined routes, UDRs. And this needs to be attached to all the subnets from where the request will be raised. Similarly, if we want the communication to happen from VM1 of virtual network C, and this communication needs to happen with virtual machine 1 of virtual network B, in that case, we need to define a routing table with the user-defined routes and attach it to the subnet from where the request will be raised. Let us now head to our demonstration. If this is not clear until now, it will become clear after you see the demonstration. Here I am on my Azure portal. And before I jump into the demonstration on how to configure the network virtual appliance to act as a router and how to set up the user-defined routes for communication between the spoke virtual networks via this network virtual appliance, let me show you the configuration that I already have. So I'll click on virtual networks first and I'll show you all the virtual networks that I have configured. I have three virtual networks. One is VNet A, then we have VNet B, and then we have VNet C. VNet A is the hub virtual network and it has an IP address space of 10.0.0.0/16. And if I click on the subnets, it will show me three subnets: subnet 1, subnet 2, and DMZ. Now, I told you that this DMZ is Demilitarized zone and it has an IP address space of 10.0.3.0/24. One more thing before I move out is I'll click on peerings under settings, and here I have two peerings. One is between virtual network A and virtual network B, and the second one is between virtual network A and virtual network C. To see the details, I'll click on the peering between virtual network A and virtual network B. Here, the peering link name is VNet A and VNet B. It is showing that this is this virtual network. And if I look down here, it shows me the address space of 10.10.0.0/16. I'll click on cancel, and similarly, I can click on the peering between virtual network A and virtual network C. So this peering is between this virtual network and the address space of 10.2.0.0/16. I'll click on cancel again here. And if I click on the second virtual network, which is virtual network B, I'll show you that similar kind of peering exists between virtual network B and virtual network A. In case you're not aware of how virtual network peering is done, please feel free to pause this video and go and watch the previous part of this series where I've explained in detail what virtual network peering is and how it is done. Now, if I click on the overview, it will show me the address space for this virtual network, which is 10.10.0.0/16. And I can click on subnets to see the subnet details, and it has two subnets, subnet 1 and subnet 2. Similarly, when I click on VNet C, it will show me the two subnets that this virtual network has. And it has an IP address space of 10.2.1.0/24 for subnet 1, and for subnet 2, it is 10.2.2.0/24. So that's about the virtual network. Let me click on the search bar, and here I already have the virtual machines. So I'll click on the virtual machines icon, and here I have 6 virtual machines. The first one is VNet A NVA, which is for the network virtual appliance. And then we have other virtual machines which belongs either to virtual network A, virtual network B, or virtual network C. And each have the specific names so that you can make out which virtual network they belong to. So let me click on VNet A NVA. On the right hand side, you will see that it has a public IP address here, and it belongs to this DMZ subnet of virtual network A. It also has a static private IP address of 10.0.3.4. One more thing. So I'll click on networking here, and then I'll click on the network interface. Once I'm there, I'll click on IP configurations. And one very important thing to note here is for IP forwarding, I have already enabled this. So this is required for routing. In your case also, you need to enable this setting. Other than that, you need to click on this particular IP config 1. Once you're there, you need to change the assignment from dynamic to static. So it needs to have a static private IP address. And that's what I have done. So I'll go back to virtual machines, and then I will click on VNet A VM1. Here, this is under subnet 1 of virtual network A with a public IP address and one of the private IP addresses. And similarly, we have VM2 of VNet A. If I click on VM1 of VNet B, this virtual machine belongs to subnet 1 of virtual network B. This also has a public IP address and also it has a private IP address. But these private IP addresses, apart from the network virtual appliance, are dynamic. The only static private IP address is for the network virtual appliance. Similarly, we have VM1 of virtual network C. This belongs to subnet 1 of virtual network C. So here it is with a public IP address and a private IP address. So that is it from the configuration part. Next step is to configure the network virtual appliance. And for that, I'll be RDPing into the network virtual appliance virtual machine. And once I'm there, I'll show you that I already installed the RRAS role on that particular server. And the only task remaining is to configure the RRAS role. So I'll be configuring the remote and routing access server. Once that is done, I'll come back to the Azure portal and define the user-defined routes and then show you how the communication happens between the virtual machines or the workloads between different virtual networks. So let's go on to our virtual machine. I am on my network virtual appliance, and if you see here, I've already installed the role remote access, but it is not yet configured. If I click here, it shows the warning and it says post deployment configuration is still pending. Before I do that, let me open the command prompt. I'll type in cmd. I'll click on the command prompt, and once I'm there, I will type in host name. So it shows me that this virtual machine is VNet A NVA. Now I'll do an IP config just as a confirmation that this is the 10.0.3.4 IP address machine. So this is the network virtual appliance. Let us also see that since we have already paired virtual network A with virtual network B, if I try to ping one of the virtual machine IP addresses from virtual network B, I will be getting the response. So for that, if I do a ping for 10.10.1.4 and hit enter, I will see a response coming from this particular virtual machine. So the virtual network peering is working here. One more thing before we start configuring the network virtual appliance is that we will go to the virtual machine of virtual network B and try to ping the virtual machine of virtual network C and see if the ping receives a response. Here I am on virtual machine 1 of virtual network B. If I click on the search bar and type in cmd, I'll try to open the command prompt, and here if I type in hostname, it will show me VNet B VM1. I will do an IP config as well just as a confirmation, and it has an IP address of 10.10.1.4. So we are good with this. Now what we need to do is ping the virtual machine of virtual network C. So I'll do a ping and then I will type in the address 10.2.1.4 and hit enter. Here you will notice that no response is received, rather the request is timed out. Let's also open the virtual machine 1 of virtual network C. Here again, I am on virtual machine 1 of virtual network C. To confirm that, I'll click on the search bar again, type in cmd and then click on command prompt. Once it opens, I will type in hostname and it will show me that the name is VNet C VM1. I'll type in IP config, hit enter, and we can see that the IP address is 10.2.1.4. if I try to ping the IP address of 10.10.1.4, which is the IP address of virtual machine 1 of VNet B, and hit enter, no response will be received and the request will be timed out because they are not peered network. Now, if I go back to the virtual machine of virtual network A, which is peered with virtual network C, and try to ping that virtual machine, which is 10.2.1.4, and hit enter, I will be receiving a response because these two virtual networks are peered. So, in order for virtual machine 1 of virtual network B, which is the spoke virtual machine, to communicate with virtual machine 1 of virtual network C, we need to configure the network virtual appliance and then define the user-defined routes. So for that, I'll click on Tools and then click on Routing and Remote Access. Once I'm there, I'll right-click on it and click on Configure and Enable Routing and Remote Access. Here we get a wizard for Routing and Remote Access Server Setup. So I'll click on Next, choose Custom Configuration, click on Next again, and then from here, I'll choose LAN routing. Once that is done, I'll click on Next again and then click on Finish. Once this complete, it will ask me for starting the service. So I'll click on Start Service and wait for the service to be configured and started. Now you see that the icon has changed from red to green and I have different options here. I have IPv4 and IPv6. Next is to configure the static routes within IPv4. So I'll expand IPv4, right click on static routes and then click on new static route. So we will be creating two static routes, one for VNet B and the other one for VNet C. So for VNet B, we have the destination as 10.10.0.0/16 and then the network mask is 255.255.0.0. For the gateway, it is the gateway of this particular machine. So if I click on the command prompt and if I see here, the default gateway is 10.0.3.1. And how did it come up? It's simple. You just need to type in ipconfig and you will get the IP address and default gateway of this particular machine. So this gateway has the routing information for all the virtual machines within the spoke virtual networks. So I'll minimize this, come back to our configuration, and here I need to give the IP address of the default gateway, which is 10.0.3.1. Once that is done, I'll click on OK. And I'll right click on static routes again and click on new static route again. The destination this time is for virtual network C. So for that, I'll type in 10.2.0.0/16 and then for the network mask, again it is 255.255.0.0. For the gateway, again, it's the gateway of this particular machine, which is 10.0.3.1. I'll click on OK again and the static routes have been defined. Now that this configuration is done, let me close this first and now go to my virtual machine on virtual network B. So if I come here, you will see that the host name was VNet B VM1. Let us now try to ping the virtual machine on the other spoke virtual network, which is the VNet C. So if I type in ping again, ping 10.2.1.4 and hit enter, it still results in request timed out. Why? Because we have not yet created the user-defined routes. For any of the subnets of virtual network B, it doesn't know where to route the request to. So the request should be routed to the network virtual appliance and the network virtual appliance knows where to forward that to. So let's go ahead on our Azure portal and configure the route table. We are back on the Azure portal. From the search bar, type in route tables. Click on the route tables. Once we're there, I'll click on create. Once I'm on the create route table page, the subscription is pre-selected for me, which is Azure Training. That's the only subscription that I have. For the resource group, I will select ATCSL India. For the region, let me select Central India and I'll give it a name of ATCSL route. I'll click on review and create. And once everything is validated, I'll click on the create button. It will take a couple of minutes and the routing table will be deployed. After it is done, we will have to configure the user-defined routes. Now that the deployment is done, I'll click on go to resource button and then under routes, I'll click on add. For the name, I'll give it a name of route to VNet C. For the address prefix destination, I'll click on the drop down and I'll choose IP addresses. For the destination IP address, I'll give the IP address range of VNet C. So it is 10.2.0.0/16. And for the next hop type, I will choose virtual appliance. The next hop IP address is 10.0.3.4. And this is the IP address of my network virtual appliance virtual machine. Once this is done, I'll click on add. And this will add a route. Once this is done, I'll click on subnets and add this route to the subnet. I need to associate it. So for that, I'll click on associate. And for the virtual network, by default, it is showing me VNet A, which is incorrect. I need to click on the drop down and select VNet B and attach it to subnet 1 of VNet B. If you remember, I told you that for each of the routes that I define, I need to attach it to all the subnets from where the request will be triggered or from where the request will be raised. So for now, I'm attaching this to subnet 1 of virtual network B if I want similar kind of request to be flown from another virtual machine which is in the other subnet to virtual network C, I will have to create a new association. So let's add that. Click on OK. And once this is done, I can click on the associate button again. Here again, for the virtual network, I will choose virtual network B. You will notice that subnet 2 is automatically selected because subnet 1 was already done. So I'll choose subnet 2 and then click on OK. Now that both the subnets are associated with this particular route, any request for connection that is raised from either of the VMs in either of the subnets of virtual network B will be able to communicate with any of the virtual machines in any of the subnets of virtual network C. Now that this is done, we need to create a similar kind of route for our virtual network C. So I'll click on the search bar again, click on the route table, and then click on create. On the create route table page, the subscription is pre-selected. For the resource group, I will choose ATCSL India. For the region, I will choose Central India and then give it a name of ATCSL VNet C route. Once everything is done, I'll click on review and create. And after it has been validated, I'll click on the create button. Again, it will take a couple of minutes and this route table will be deployed. After this is deployed, I'll create the user-defined routes. It is done now. I'll click on go to resource and click on routes. Click on add. I will give it a name of route to VNet B. For the address prefix destination, I'll choose IP address. For the destination IP address, I need to give the IP address space of virtual network B, which is 10.10.0.0/16. For the next hop type, I'll click on the drop down and choose virtual appliance. Again, the next hop address should be 10.0.3.4, which is the IP address of my network virtual appliance virtual machine. After everything is done, I'll click on add. And this route will be added. Once the route has been added, I need to associate this particular route to the subnets. So I'll click on subnets here, click on associate. And here again, from the virtual network dropdown, I'll click on the dropdown and choose virtual network C. For the subnet, Subnet 1 is OK. I'll click on OK to add that. And once that happens, I'll click on the associate button again. This time, I'll choose VNet C again, but for the subnet, it should be subnet 2. I'll click on OK. And the user-defined route will be associated with both our subnets of virtual network C. Now that this configuration is done, any request that is raised from any of the workloads or any of the virtual machines from within virtual network B for any of the workloads or any of the virtual machines within virtual network C and vice versa will work. So how do we confirm that? Let's go back to our virtual machine 1 of virtual network B and try to ping the virtual machine 1 of virtual network C. I am on my virtual machine 1 of virtual network B. So what I'll do is I'll again try to do a ping to my virtual machine on virtual network C. If I hit enter, now this time I get a response from this particular virtual machine, which is 10.2.1.4. We can do a similar test on virtual machine 1 of virtual network C. Let's do that now. So here I am on my virtual machine 1 of virtual network C. Let's do a ping to my virtual machine 1 of virtual network B. If I hit enter, you will see a response from 10.10.1.4. So the network virtual appliance works with the help of user-defined routes. And that is how the network virtual appliances work. I am back on my Azure portal and hope you now completely understand what a network virtual appliance is and what are user-defined routes and how they are configured. But before we sign off, let's do one last thing. Let's make it a little more complex. What if I create an Azure firewall and add it to my hub network without changing any other configuration? What I want is that any traffic that is coming from the internet to any of the spoke virtual machines should be routed through my network virtual appliance. That is why I added the subnet as a DMZ, Demilitarized Zone, because that is one of the ways on how you can configure a demilitarized zone so that any internet traffic coming for any of the virtual machines in this spoke virtual network should be routed through our firewall. So for that, I need to create an Azure firewall. But before I do that, let me show you that I created two additional subnets. The first one is Azure Firewall Management Subnet and the other one is Azure Firewall Subnet, and these two were created within the VNet A Hub Virtual Network. Now that this is done, what we can do is we can click on the search bar and search for firewall. And the first option says firewall. I'll click on it. Once we are there, I'll click on create. And once I'm there on the create a firewall page, I need to select the resource group. I'll choose ATCSL India. For the name, I'll choose DMZ firewall. The region is Central India. I'll choose that. For availability zone, I'll let it remain at none. I'll scroll down. For the firewall SKU, I'll choose basic. I'll scroll down further. For the firewall policy, I don't have a policy, so I'll click on add new. I'll give it a name of basic policy. Again, from the region, I'll choose Central India and then click on OK. For the virtual network name, it is coming in red because the create new radio button is checked. I'll choose use existing and then choose the virtual network, which is virtual network A. For the public IP address, I don't have an IP address that was created specifically for the firewall, so I'll add a new public IP. I'll call it FWPIP and click on OK. For the management public IP address, again, I do not have an IP address for the management public IP address, so I'll click on add new. For this one, I'll give it a name of FWMGMT PIP. I'll click on OK. And after every detail has been filled, I'll click on Review and Create. I'll wait for the validation to happen, and once it has passed the validation, I'll click on Create. The firewall is getting deployed, so we'll wait for this deployment to be completed and we'll start our further configuration from there. The configuration of the firewall is now complete, and the next step we need to do is to configure the user-defined routes. Why is that necessary? That is necessary so that any of the traffic coming from the internet for any of the virtual machine within the virtual network B or virtual network C should be routed via our network virtual appliance, acting as a demilitarized zone so that there is no direct traffic. To do that, I'll go back to my user-defined routes. I'll click on search and then I'll click on route tables. Once I'm on the route tables page, I'll click on ATCSL route. I'll click on routes under settings and I'll click on add. And for the route name, I'll give it a name of from internet to make it more precise. Now for the address prefix destination, I'll choose IP addresses. For the destination IP, I will type in 0.0.0.0/0. So this IP address of 0.0.0.0/0 represents any traffic coming from any of the sources, which is from the internet. So that is what I have given here for the destination IP addresses. For the next hop type, I will choose virtual appliance, but here for the next hop address, I need to give the IP address of the firewall. In order to do that, I'll click on my other tab and I'll click on the search bar. I'll search for firewall, click on firewalls and click on the DMZ firewall which we just created. The firewall private IP address is 10.0.5.4 and that is what we are going to give here. So it is 10.0.5.4. This is done. I'll click on add. We do not need to associate this to the subnets because it is already associated with both the subnets of virtual network B, but we need to create a similar route for virtual network C. So what I'll do is I'll click on the other route table, which is ATCSL VNet C route, and under routes, I'll click on add. Here again, I'll type in the name as from internet. For the address prefix destination, I will choose IP addresses. For the destination IP address, again 0.0.0.0/0 to represent any of the traffic coming from the internet. For the next hop type, it is virtual appliance and the next hop IP address is 10.0.5.4. So now that this is done, I'll click on add. Here again, no association required because the routes are already associated with the subnets of virtual network C. Now before we test this, let me show you something. So if I click on my other tab, I'll click on the search bar, I'll go to my virtual machines. And from here, if I click on VNet B VM1, it has a public IP address of 20.219.55.113. And similar is the case for VNet C VM1, it has a different public IP address which is 20.235.66.136. Whereas for the firewall, if I click on my other tab, I can click on the search bar, I'll click on firewalls, I'll click on DMZ firewall. It will show me the public IP address. I can click on FWP-IP and here I have the public IP address which says 20.235.106.2. All the traffic will be routed via my firewall. Also, let me show you the virtual machine's network interface card. So I'll go to my other tab and here on the virtual network C VM1, I'll click on networking and then I'll click on the network interface card and under help, I'll click on effective routes. Here you will notice there are certain active routes, but for the internet, this default route is invalid. And the valid one is the one that we just added. It is a user-defined route and it is for the internet. what it is doing is, it is taking us to the virtual appliance, and the next hop IP address is the firewall. So any traffic coming from the internet is first going to the firewall, and from within my network virtual appliance, I'll be able to access my virtual machines within the virtual network C. Similarly, if I go back to my virtual machines again and click on VNet B VM1, under networking, if I click on the network interface, and then again under help, I'll click on effective routes. Here also it will show the similar kind of configuration where the default traffic from the internet has been marked as invalid, which is this one. And we have the user-defined route which is active. And this is how you can set up a demilitarized zone. And this is one of the methods apart from Azure Bastion. And now to test the waters. To do that, what I'll do is I'll go to my virtual machines. And from here, if you see the virtual network B VM1, it has a public IP address of 20.219.55.113. I'll just copy this, and if I open an RDP session, paste the IP address and click on connect, it will try to make a connection, but it will fail, saying that remote desktop can't connect to the remote computer for one of these reasons. So this connection could not be established from outside, from the public internet. Similarly, if I copy the public IP address of VNet C VM1 and try to make a connection, it will give me this similar error and will not be able to connect. So in order to connect to these virtual machines, what I need to do, I need to connect via my virtual appliance, which is VNet A NVA. I'll copy the IP address and then paste it for the RDP and click on connect. It will ask me for the password. So I'll give a password that I have and click OK. Now that I am within my NVA, which is a network virtual appliance, I'll click on the search bar, search for remote desktop, click on the remote desktop connection option and try to put in the private IP address of virtual machine 1 from virtual network B. So I'll copy the private IP address, go to my virtual machine and paste it for the IP address of the computer. I'll click on connect. It is asking me for the user ID and password. So I'll give that and click on OK. So it was able to connect. I'll click on yes. And here you go. I'm able to connect to VM1 of virtual network B. And that is from within the network virtual appliance. We can do a similar test for my virtual machine within virtual network C. So for that, I'll again minimize this. Go to my VM1 of virtual network C. Copy the private IP address from here. Go back to my network virtual appliance. I'll open another RDP session, click on the remote desktop connection, paste the IP address here and click on connect. It will again ask me for the user ID and password. I'll click on OK. I'll click on yes, and I was able to connect to my virtual machine within the virtual network C. So that is how you configure the demilitarized zone. I hope now you completely understand what network virtual appliances are and what are user-defined routes, and how you can use VNet peering, network virtual appliance and user-defined routes to create some complex infrastructure. And you can also set up the demilitarized zone using network virtual appliance and user-defined routes. Thank you so much for joining in this session, and if you like the video, just give a thumbs up and subscribe to my channel, and it motivates me to create more such informative videos for you. And until we meet next time, keep exploring the cloud.